The EB-707 Cóndor was an iconic airborne early warning and command, or shortly AEW&C aircraft with its distinctive shape. It served in the Chilean Air Force for 27 years and has gained the hearts of military aviation enthusiasts. Today, we're investigating the EB-707 Cóndor, one of the most intriguing and bizarre-looking AEW&C aircraft. The EB-707 Cóndor was a giant bird which you couldn't turn. Yes, its market success was too limited. Only one operational aircraft was ever created. It never played a critical role in a crisis or war. Still, the Cóndor was unforgettable. Even though it was a pure military aircraft, it looked cute, like the famous internet cat whose nose was stung by a bee. Before we start, we owe special thanks to RL Videos and Patricio Muñoz for allowing us to use their beautiful footage. The aircraft was developed by Israel, who knew the importance of early warning by experience. This country had won an unprecedented victory in 1967 by using the lack of early warning capability of its Arab neighbors. In 1973, this time due to the sudden attack of the Arabs, Israel had faced the threat of total annihilation. The early warning capability was vital for a country with minimal geographic depth. So, in the early 1980s, the Israeli Air Force required a more advanced AEW&C aircraft to replace or supplement its existing E-2C Hawkeyes when its Arab neighbors began to acquire more advanced combat jets. The local Alta Electronics Industries company, today's Alta Systems, developed the ELM-2075 Phalcon to meet this requirement. Taking its name from an acronym of Phased Array L-Band Conformal, the system employed an advanced active electronically scanned array radar rather than a rotating disc radar mounted in a bulky dome above the aircraft. This design had many advantages, such as it could track numerous targets in multiple sectors simultaneously. For trial purposes, Israel mounted the radar onto the Boeing 707-320B airliner. The aircraft had a 360-degree radar coverage. It also had an in-flight refueling capability. The new aircraft was never officially introduced to the Israeli Air Force service, even though it kept flying until the early 2010s. On the other hand, in 1989, Chile, which had similar geographical conditions to Israel with its long and narrow lands, ordered one ELM-2075 Phalcon. The system was mounted onto a former Boeing 707-385C of the local airline company LAN Chile, today's LATAM Airlines. There were a few reasons for this decision. The US had some limitations in selling advanced defensive systems to South American countries. Israel had acted as a backdoor to bypass this restriction. It had executed many joint military projects with Chile, which made this country a trustworthy partner. Besides, the new aircraft, designated as EB-707 Cóndor by the Chilean Air Force, was more advantageous than the existing AEW&C platforms with a rotating disc radar. It was also one-third the price of the E3. The Israeli IAI company carried out the integration and necessary modification works. The aircraft made its maiden flight in 1993 and was officially delivered to the Chilean Air Force. However, the command system software required some corrections. So, the Cóndor could not become fully operational until 1995. The semi-monocoque fuselage was all metal. Due to the integration of radar and necessary mission equipment, some parts were strengthened. The aircraft had all-metal two-spar fail-safe wings. Flaps and spoilers were operated hydraulically. Naturally, the electric systems and wiring of the aircraft were redesigned. The aircraft had the ELM-2075 Phalcon radar, ELM-2610 friend or foe identification system, ELK-7031 ELINT and ELL-8312 Commit equipment, central computer, 11 automated workstations, and necessary communication systems. The original Israeli aircraft used the solid-state L-band ELM-2075 conformal array radar with 6 panels of phased array elements, 2 on each side of the fuselage, 1 in an enlarged nose cone, and 1 under the tail. However, the Cóndor had no tail panel. so its radar coverage was only 260 degrees. The lateral panels were approximately 12 meters long and 2 meters wide and were mounted on floating beds to prevent airframe flexing from degrading the radar accuracy. Each array consisted of 768 liquid-cooled transmitting and receiving elements. This arrangement allowed for circular electronic scanning in azimuth. The ELM-2075, whose operating frequency range was between 1215 and 1400 MHz, could determine target coordinates in adverse weather conditions with high accuracy. It operated on a pseudo-random set of frequencies. The Phalcon updated aircraft positions on operator screens every 2 to 4 seconds, while this time is 20 to 40 seconds for conventional AEW&C aircraft with a rotating disc radar. These two features made the ELM-2075 almost immune to detecting and jamming while eliminating false alarms. The radar's optimum detection ranges were 500, 370, 180, and 100 kilometers for a ship, a fighter aircraft, a helicopter, and a cruise missile, respectively. It could simultaneously track up to 100 targets, while at the same time it could direct over a dozen fighters toward air and ground targets. The ELM-2075 employed a flexible time-space energy management technique. The radar operator could set the beam width to monitor dedicated sectors. So, the radar could limit the surveillance range to the battle zone or other areas of interest. The optimized detection and tracking mode allowed using a high scan rate and beam shapes optimized for each maneuvering and high-value target to ensure tracking performance. The ELM-2075 controlled each element in phase and amplitude. Thus, it could continue the operation even if some units malfunctioned. The ELM-2610 friend or foe identification system worked in modes 1, 2, 3, and C. Military-only Mode 1 and 2 identified the detected aircraft's type or mission and unit code or tail number respectively. Mode 3 was used for both military and civilian aircraft and detected their identification codes assigned by the air traffic controller. Mode C determined the target's altitude using the 𝗩𝗗𝗗𝗓 code. The ELM-2610's interrogator ensured the identification of an object by 1 or 2 interrogation packages within 2 seconds, while the traditional method required more than 12. The ELL-8312A ELINT equipment provided detection, classification, and identification of air, sea, and land-based radar sources in the frequency range between 70 to 18,000 MHz. It had a 360-degree azimuth coverage area at a range of up to 450 kilometers. The ELK-7031 COMET equipment detected emissions from air, sea, and land-based radio communication stations in the frequency range between 3 to 3,000 MHz. It could find the direction of a radio communication and intercept transmitted messages. This equipment could also locate a person in distress, making the Cóndor a valuable asset for search and rescue missions. Each automated mission console had a dual-color multifunctional displays, a control panel, and an intercom system. A standard mission crew, excluding the flight crew, consisted of 13 people. Alongside the shift supervisor, radar, ELINT COMET equipment, communication systems, tactical maps, and data transmission equipment controlling duties were each assigned a 2-person crew. Besides, another 2 were tasked with monitoring the technical condition of the onboard mission systems. The 4-person flight crew consisted of a pilot, co-pilot, flight engineer, and navigator. If the Cóndor also performed airborne command missions, a separate command staff worked in a dedicated room. This area had additional workstations, extra communication and data transmission equipment, and a large screen displaying the operational situation. The Cóndor could perform 10-hour patrols. So, the aircraft also had 6-person resting area with kitchen facilities and restrooms. Chile was the only operator of the aircraft. In a standard mission, the EB-707 Cóndor had a 17-person crew. The aircraft had a length of 48.61 meters, a wingspan of 44.42 meters, and a height of 12.95 meters. Its wing area was 283.75 square meters. The Cóndor had an empty weight of nearly 78,000 kilograms and a maximum takeoff weight of over 160,800 kilograms. Four 80.1 kilonewton Pratt & Whitney JT3D3B turbofan engines provided a top speed of 853 kilometers per hour. The patrol speed of the aircraft was 520 kilometers per hour. Its range was 6,920 kilometers. The Cóndor could climb to an altitude of 8,700 meters, in other words, 28,545 feet. The Cóndor served in the Chilean Air Force's 10th Aviation Squadron, part of the 2nd Air Brigade. It was deployed at the 𝗩𝗗𝗄 Air Base in Santiago. The 10th Aviation Squadron operated the other three Boeing 707s. Two aircraft were used for transport missions, while one was a converted tanker aircraft called KC-707 Águila. Even though the Argentine military threat had already begun to fade after the 1982 Falklands War, it was still a matter for the Chilean security in the early 1990s when the Cóndor was ordered. Besides, Chile had border disputes with Bolivia and Peru. Yet, during its service, the Cóndor was never a part of a serious crisis. Still, it was the superstar of many air shows in Chile. In 2022, the Chilean Air Force replaced the aircraft with three E-3D Sentry AWACS aircraft donated by the United Kingdom. As mentioned, Israel used its other Boeing 707 base version for trials for many years, but never officially accepted it to its Air Force service. Yet, the experience from the ELM-2075 was used to develop more advanced versions, the ELW-2085 and the ELW-2090. India selected the ELW-2090 for its three IL-76A50 based AEW&C aircraft. Besides, Israel, Italy and Singapore used Gulfstream G550 based platforms with the ELW-2085 radar. Especially its nose section gave the Cóndor a distinctive appearance. Still, it was not the first in this manner. The British Nimrod AEW-3, which made its maiden flight in 1980, also had a hooked nose. Yet, this project was cancelled in 1986 after 3 prototypes and 8 production version aircraft were manufactured. So the popularity of this distinctive shape belonged to the Cóndor. This aircraft was the new world vulture, as its name suggested. It was not created to kill the enemies. Its job was to perform vulture circles on those who were about to die. Thanks for watching our video. And please don't forget to subscribe to our channel and click the bell button to be notified of our new videos. Also, you can now click the join button to support our channel. And as always, we would greatly appreciate all of your likes, comments and shares.